All right, so here's your exam review, exam prep. I'm going to do the even numbers right now. So write out the first 5 terms of the sequence. So first we're going to plug in 1. That is 4 over 7. Then I'm going to plug in 2. That's 16, and 9 plus 4 is 13. I'm going to plug in 3. That's 64. And then 27 plus 4. Oh, we have 2 more. 4 to the 4. So 256 over 85. And then one more time to the 5. That's 1024 over 247. Number 4. Given the pattern, write the explicit rule for the sequence 2, 4, 8, 16, 32. So it's pretty obvious there's a common ratio of 2, and so the rule would be a1, 2 to the exponent n minus 1. Number 6. During a 5-year period, a company doubles its profit each year. If the profits at the end of the 5th year are $176,000, then what are the profits for each of the first 4 years? So if it doubles each year and the 5th year is that, then I'm just going to be simple. So I know the ratio is 2, but I'm working backwards. And so I'm just going to take 176,000. I'm going to divide it by 2. And then divide by 2. And then divide by 2. And then divide by 2. So that means we have 11,000. Then we have 22,000. Then we have 44,000. Then we have 88,000. And then if you double 88, you get 176. So year 1, 2, 3, and 4. And then year 5 was there. Number 8. The sequence is defined recursively. Write the first 4 terms. So a, n minus 1, means the term before it. So the term before, in this case, so the first term is 2, and then I go 2 times 2 plus 5. That's 9. Then I go 2 times 9 plus 5, 18 and 5. Then I go 2 times 23, 46 plus 5. Then I go 2 times 51, it's 102 plus 5. And those are the first, it says first 4 terms. Be a good reader, right? So those are the first 4 terms. So can you do it recursively? So expand and calculate the sum. So for these, we don't have a formula. We have to expand it and then just add it up. So for number 10, plug in 1 and you get 1/5. Plug in 2 and you get 2 cubed, 8/5. Plug in 3, you get 27 over 5. Plug in 4 and you get 64 over 5. Plug in 5 and you get 125 over 5. And then you just add up all of those. They all have the same denominator, so that should be easy. So 1 plus 8 plus 27 plus 64 plus 125 divided by 5. It actually comes out to a nice number. Number 12, again we're going to expand it. There's no rule, this is not geometric, not arithmetic, just a series. So plug in 1, and 1 plus 1 is 2, and 2 squared is 4. Plug in 2, 2 plus 1 is 3, 3 squared is 9. Plug in 3, 3 plus 1 is 4, 4 squared is 16. I can even see a pattern in terms of now what I see. And I stop at that. So 4 plus 1 is 5 squared, 25. So that's what I'm adding up. So we got 41, 50, 54. Express the sum using sum notation, then find the sum of the series. So 3 plus 6 plus 9 is arithmetic. So we're going to do we're going to work backwards. We're going to write this as in sum notation. We'll just start with 1. So n equals 1. I don't know how many terms there are there, but I know the rule. And so the rule to write down would be the common difference is 3, and then n minus 1 plus 3. So there's the rule. I just need to know how many terms there are. So to figure out how many terms there are, I'm going to take 18. I'm going to use that rule, and I'm just going to solve for n. So you can subtract 3, you can divide by 3, and you can add, and you can see that there are 6 terms. So 1 through 6. Write an explicit rule, then find the indicated term. So here we have a sequence. We're told it's arithmetic. So notice that the common difference is negative 5. So the rule would be negative 5, n minus 1, minus 10, and then find the 12th term, just plug in 12, and solve it. Number 16. Oh, I did 13. I didn't mean to do an odd number. Oh well. 16. Write an explicit rule for the arithmetic sequence described below. So I don't know the common difference, but I can find it the same way I would find slope. I would go negative 48 subtract negative 18, and I would go 13 subtract 10, like the slope formula. So the common difference is, and it's going to be negative, right? Yeah, so negative 10. So the rule would be negative 10, n minus 10 minus 18. Notice I used the 10th term. And then it says find the geometric means between them. So the means would be use negative 10, so it would be negative 28, negative 38. That would be 11 and 12. That's it. There's just 2 means between those. Number 18. Here, let me do it with a little more room here. So to find the common difference is the slope formula. I'm going to go 113, subtract 68, and I'm going to go 14, take away 9. So 113 take away 68. My brain isn't going to do that right now. 113 take away 68. So that's 45 over 5. So that's 9. So the rule would be an 9, n minus 9, because it's the 9th term, and then 68. So I don't need to find the first term for the rule. And then what are the means in between 9 and 14? So keep adding 9. So 68 and 9 is 77. 9 more would be 86. 9 more would be 95. 9 more would be 104. And that's it. Those are the means in between there. Can you find arithmetic sum? So I need to know the first term. I need to know the last term. The only thing I don't know is how many terms there are, and I do need to know that. So that I need to solve for first. What am I doing 19? I keep going that way. So I'm going to do 20. Let's do it again. So 1, the last term is 1225. And again, I don't know n, so I'm going to write a rule for an and then solve it. So the rule would be the common difference is 2, n minus 1 plus 1. There's my rule, and make it equal to 1225. So I'm going to subtract 1. I'm going to divide by 2, and then just add 1 to that. So I know that there's 613 terms. So now the formula to add up the first 613 terms, you take how many terms you have divided by 2, and that's the first plus the last, and then use your calculator. So let me do that. And I get 375,769. Number 22, even numbers. A theater has 24 rows and has 20 seats in the first row. So A1 equals 20 and N equals 24. The next one has 23 and 26, so I can definitely see a common difference of 3. It says how many seats are in the theater. So to find the total number of seats, 24, I take the total number of rows, and there's 20 seats in the first row. I don't know how many seats are in the last row, but I'm just going to plug in to figure out how many seats are in the last row. That would be the 24th row. You just use the rule. So the common difference, and then 24 minus 1 plus 20. So let's quickly figure that out. 3 times 23 plus 20. So there are 89 seats in the last row, and now you can put it all together. So 12 times 109, right? So in the theater, so there are 1,309 seats. 908. 1308. 1,308 seats in the theater. 24. Suppose you just received a job offer. The starting salary is $37,000, and you're guaranteed a raise of $1,500 per year. How many years will it be before you've made a total of $1,025,000? So let's start from the beginning. Is it arithmetic or geometric, and why? Because you're raising $1,500 every year, $1,500, $1,500, $1,500. That is your common difference. It's arithmetic. For me, the total means the word sum. So I need to know the first term. So we started with 37,000. I need to know how many terms there are. Well, that's what I'm looking for, how many years I have to work to get there. But I do know the end amount. So the end sum is 1,025,000. So the formula is this for arithmetic, and then I'm going to plug it in and use my calculator to solve it. So there's my formula. So Sn is 1,025,000. N I don't know. A1 is 37,000. And then An is just the rule. So the rule would be 1,500, n minus 1 plus 37,000. Oop, that should be 1,000. And that's it. Then I'm just going to use my calculator, press F2 and solve, and plug it in, and solve it. So I'm going to do that too. Almost there. So I get two answers. I'm going to round to the positive answer. So the answer is about 9.888. So it's pretty close to 10 when I round it. I'm not using negative 13.8. So how many years before you made a total? And it would take 10 years to be a millionaire. All right, 26. Write an explicit rule for the 12 terms in the sequence. So first of all, is it arithmetic or geometric? So 3, 6, so on, so no. But now I can see a common ratio of 2, right, all the way through. So the explicit rule would be 3, 2 to the n minus 1. And then the 12th term, I just plug in 12. So let's do that. So it's 6,144. Number 28. A new piece of equipment costs $68,000. For each year, the company depreciates the value by 25%. What value should the company give the equipment after 8 years? So this is a geometric situation with the percent. So it started at 68,000. This one's the tricky one. It depreciates by 25%. But how much is left of the value? So it loses 25%. How much does it keep? So every year it keeps 75%. They have to add up to 100. And then n would be 8. And then you're just finding the 8th term. We're not adding or anything like that. So 68,000.75 to the 8. So the approximate value of it would be $6,807.68. All right, turn the page. Again, even numbers we're going through. Number 30, a bicycle wheel rotates 400 times in a minute as long as the rider is pedaling. If the rider stops pedaling, the wheel starts to slow down. Each minute it will rotate only 3/4 as many times as the preceding minute. How many times will the wheel rotate in the 4th minute after the rider leaves the pedals? So this again is a geometric situation where you have 3/4 of something you're multiplying. So A1 is 400. The common ratio is 3/4 because 3/4 is what's remaining. And then I need to know the 4th minute. So we're going to write down 400 times 3/4 to 4 minus 1 and then do the work. Round to the nearest unit, so that would be 169. So how many times does the wheel rotate? And the answer is the wheel rotates 169 times during the 4th minute. 32. A football player's salary, $890,000 per year, and an annual increase of 4%. So that percent gives me a good idea. It's a ratio. What will the athlete's salary be to the nearest dollar in the 6th year? So we're not adding totally, it's just a term, but just know that 0.04% is just the increase. And so if you want to add it back to the actual salary, so it's all together, the salary and the increase, it would be 1.04. The 6th year, and of course A1, the beginning salary is $890,000. So the 6th term, $890,000. And it's 1.04 to the exponent 6 minus 1. And then you get the answer. $1,082,821 if I round it. Number 34. Can you do a sum? What type of series is this? Because it's exponential, it is geometric. So big long fraction line. A1, plug in 1, and 4 to the 1 is 4, times 2 is 8. The ratio is 4, the base. The exponent, how many terms you have? 5. And then the denominator is 1 minus 4, and that's what you put in the calculator. So if you add it up, you get 2,728. All right, 36. A small business owner made $30,000 the first year, made an additional 9%. There's an indicator that you're looking at a ratio over the previous year and each subsequent year. Find out how much he made during his fourth year of business. So n is 4, 9% is 0.09, but I need to make sure that 1 is in front, so it's the increase and what it was before together. And then A1 is 30,000. So I want to find the fourth term. So 30,000, 1.09 to the 4 minus 1. And you get $38,850.87. Oh, and then it says find his total earnings for the first 4. So if I want to then add that up, now I have the first term, 30,000, 1 minus 1.09 to the 4, and then the denominator is 1 take away 1.09. So there's the setup to add up the first 4 years. So I'll do that too right now. And you get 137,193. There it is. Let's see if I can read it properly. $137,193.87. That would be adding up the first 4. All right, number 38. Initially, a pendulum swings through an arc of 3 feet. That's going to be your A1. Each successive swing, the length of the arc is 0.8 of the previous one. That's going to be your ratio. After 10 swings, what total length? So the word total means we're going to add up the first 10. So we have 3, 1 minus 0.8 to the 10 over 1 minus 0.8, and then use your calculator. And if you round to the nearest foot, it would round up to 14. It'd be 13.389, but then it rounds up. All right, number 40. Determine whether the infinite geometric series converges or diverges, and if it does, find its sum. So 2, 1, and so on. So you can tell that when you divide, definitely converges. So what's the sum of an infinite number? You would start with A1 and then go 1 minus the ratio, and that's it. I won't even use my calculator here. The answer is 4. 42, 18 over 54 clearly is going to converge. I'm going to reduce it down. 18 actually goes in there evenly, 1/3. And then the sum of an infinite number of terms, so A1 and then 1 minus the third. So let me just do that quick. It's 54 divided by 2/3. You get 9. No. What did I do wrong? 54 divided by 2/3. There it is, 81. Just typed it wrong. Perfect. All right, coming to an end. 44. A ball is dropped at a height of 25 feet. Each time it strikes the ground, it bounces up 0.7. So already you get a sense that it's geometric, and you can see the exponential rule that you see there. The total distance the ball has traveled before the second bounce is so on, and the total distance for it is so on, and so on. Use facts about this infinite geometric series to calculate the total distance the ball traveled before it stops bouncing. I appreciate this, but I can just find it in terms of understanding it better. So it's 0.7 A1. So first it started at 25 feet. And then, if there's an infinite number of times, what would the formula be to add that up? So it's 25 over 1 minus 0.7. Switch calculators here. So 25 divided by 0.3. So by the time it stops bouncing, it'd be 83.3 feet. Last one, 46. After being struck with a hammer, a gong vibrates 72 vibrations in the first second. That definitely sounds like A1. And in each second thereafter, it makes 6/7 of it. So that's a ratio, 6/7 of the previous one. Find how many vibrations a gong makes before it stops vibrating. So that's a way of saying to infinity. So it just goes until it stops. So the infinite sum then would be 72, 1 minus 6/7. And I get 504. That's how many vibrations. All right, good job prepping for your exam. Mr. G Math, over, out.